Hello geometry, and welcome to chapter 3. This is going to be all about parallel and perpendicular lines, and in this section we are going to learn about some angle relationships that lines create when they intersect. So first we're going to look at what happens when lines don't intersect. So parallel lines, we want to be very specific about what are parallel lines. Most people know they don't intersect, but what's also important is those parallel lines have to be on the same plane, which we call coplanar. So they are coplanar and they don't intersect. So an example, when we look over at our diagram, might be line N here and line M. Those would be parallel, and notice that they each have this little arrow on them. So we know that the tick mark shows things are congruent. The little arrow shows that those two are parallel. Now we also can have parallel planes. We don't talk about them being coplanar because they are planes, but if you think about your ceiling and your floor, those should be parallel planes. So basically parallel planes don't intersect, which seems pretty straightforward. So we have plane T and plane U here are going to be parallel planes, kind of like the ceiling and the floor where you are sitting. Now we have sort of a new term. We have this term skew lines. Skew lines also don't intersect, just like parallel lines, but the distinction is skew lines are not coplanar. So it's impossible to draw a plane that would pass through both of them. So they're not coplanar and they don't intersect. So an example of that might be when I look over here, you have L and M on plane T. If I were to draw line L here down below, you could say line M and line L are skew. They won't ever intersect, and they're not on the same plane. All right, so now let's look at how we can identify some of this. So we have a diagram here, and we're going to be focusing on this point B right here. So we want to know all the situations where a line or plane that contains point B fits the following description. So lines that are skew to FG, so FG is right here, and contain point B. Well, again, you cannot draw it in such a way that I could have a plane go through it. So it has to be skew. So I'm going to draw a line here through BC. That would be skew to FG. It's not on the same plane. I couldn't draw it through AB because notice they would be on the same plane then. So then we want lines that are perpendicular to FG that go through point B. So we see this little perpendicular marking down here. So BG, line BG is going to be perpendicular to FG, but also pass through B. Then we want a line that is parallel to FG, so it has to be coplanar and pass through point B. That's where we want to pick up line AB. And then we have, passing through B, a plane that is parallel to plane FGH. So plane FGH is back here. And the problem is we don't have any markings that say that that is sitting up perpendicular and ABC, the plane in front, is also. So we don't know if those would be parallel. So in this case, we'd have to say there's none. None that we can definitely say because we don't have the markings to support it. All right. Okay, so now let's get into a couple postulates that are going to be introduced in this chapter. Remember that a postulate is a statement we just accept without proof. So that means it'll be pretty basic. So this first postulate says that If I have a point P and I have a line, so point P is not on that line, it's asking how many parallel lines could pass through P and be parallel to L. And the answer is 1. There is exactly one line that can pass through P that is parallel to line L. And another way so that we can denote parallel in symbols is we use these two little lines right next to each other. So instead of always writing the word parallel, I can just use these markings. Okay? So that kind of makes sense. Remember, it has to be coplanar. If you think of your paper as a plane, P is on the plane, line L is on the plane, and there's only one line that's possible to draw through that. Our second postulate is the perpendicular postulate, and it kind of is the same idea. If I have a point P and I have a line L, there is only one line possible that can pass through P and be perpendicular to line L. So there is exactly one line again through P that is perpendicular. And again, remember, we use this upside down T represents perpendicular, so I don't have to always write it out, to line L. Line L, almost forgot my E there. All right, now having said that, I also want to talk about just the concept of perpendicular from a point to a line, because this will come up. And this is known as the shortest distance from a point to a line is always along the perpendicular. And it kind of makes sense when you look at this. Here's point P, here's line L. If I draw any other line that is not perpendicular, it looks like the hypotenuse of a triangle. And we know a hypotenuse is always the longest side. We want the shortest distance. That is always going to be along the perpendicular. All right, let's take a look at identifying some of these things. So we start off with name a pair of parallel lines. So what we are looking for again are those similar markings, and we can see that you have a single arrow here and we have a double arrow over here, which is a way of showing that you have two different sets of parallel lines. So we could call WX, so line WX is parallel to line YZ. And if we needed to name more, we could have said VU is parallel to RQ. I think that's a Q, yeah. But we only needed one pair. Name a pair of perpendicular lines. So now what we're looking for are the little box that shows us those are going to be intersecting at a right angle. So I have ST, line ST is perpendicular to line VU or UV. Remember, it doesn't matter what order you say a line in. It's only the ray you really have to worry about. Okay, is WX, so WX is right here, is WX parallel to QR? And hopefully you can see that that's a no way. All right, how about is ST, which is right here, perpendicular to QR? Well, we know that QR is parallel to UV, so they're going in the same direction, and UV is perpendicular to ST, so that means, yes, this also would be at a right angle. Okay? Okay, so one of our main focuses in this chapter is going to be on the relationship between lines and a transversal. A transversal is just a fancy word for a line that crosses other lines. You transverse, meaning you go across something. So we a lot of times denote a transversal with line T. So it crossed two other lines. And what happens is it creates a relationship between the angles formed by the lines and the transversal. And there will be two different relationships. There'll be a relationship with the actual lines and with the transversal created. So let's look at this first one. This relationship we refer to as corresponding angles. And I will tend to abbreviate that as a CA for corresponding angles. Now the way this works, notice that angle 2 and angle 6 in the black are going to be corresponding angles. Why? Because they're both on top of their respective lines and they are both to the right of the transversal. So they correspond in the same way to both their lines and the transversal. So angle 2 and angle 6 would be an example of corresponding angles. We actually have more. If you notice, I kind of wrote in some numbers there. You could pick off several more pairs of corresponding angles. For instance, well, you could try it yourself first, and then I will go ahead and write down another pair. We have angle 1 and angle 5. They are both also on top and to the left of the transversal. We also have angle 3 and angle 7 are corresponding angles. They're both below their respective line and on the left of the transversal. And then the last pair you have would be angle 4 and angle 8 are also corresponding angles. So corresponding angles, they correspond in the same way. Our next type of relationship we're going to look at are called alternate interior angles, and I tend to abbreviate that AIA. And so you have the concept here. If I've got two lines and a transversal going across it, well, between those two lines is what we call the interior. It's between the two lines. And then alternating means that you are on alternating sides of the transversal. So notice that in the black we have angle 4 and angle 5. They are both interior to the two lines, but they are on alternate sides of the transversal because there's always going to be those two relationships. So angle 4 and angle 5 are alternate interior angles. And we have one more pair. Notice that angle 3 and angle 6 are also interior but on alternate sides. So if we have alternate interior, it kind of makes sense that we would also have alternate exterior angles. And hopefully you're catching on here. I abbreviate this AEA. And so again, so out here, not between, that is considered exterior to the two lines. And the same concept of alternate sides of the transversal. So we can see in black that we have angle 1 and angle 8. Those are both exterior to the two lines and on alternate sides. And you have one more pair, which would be angle 2 and angle 7. And then the last relationship we're going to be looking at here, it had a better name in previous geometry books, but I guess we can deal with this one. This is when we're going to have, again, interior, but on the same side of the transversal. So we used to call them same side interior, which made a lot of sense. But your book, in its wisdom, decides to call them consecutive interior angles. And it does give us kind of a nice abbreviation, so we call these ones the CIA, consecutive interior angles. And they're consecutive, so I guess that makes sense. All right, so we can see here angle 3 and angle 5 are consecutive interior, and we also have on the other side 4 and angle 6. They're on the same side of the transversal, but interior to the two lines. All right, so then let's practice identifying some of these relationships. And again, this is a good time for you to maybe pause the video and try it on your own, see if you get it right. So I always like to draw the transversal. So we notice that angle 1 and 5 are on the same side, and they are both to the left, so they are what we call corresponding angles because they correspond in the same relationship to the two angles. Now in example B, we have, so remember this would be between the two lines because this is going to be your transversal. So my angles are on alternate sides of the transversal and exterior. That makes them alternate exterior angles. And lastly, we notice that we have two angles that are interior and on alternating sides. So we call those ones alternate interior angles. All right, so I hope that is starting to be recognizable. In this next example, this is a little crazy, but we are going to go through this. Okay, we want to identify all the pairs of angles that are corresponding angles. So that means that they have to be in the same relationship. I'm not sure that I want to do all of these. So that means we have to choose a transversal first. So let's choose this transversal right here. Okay, so if that is a transversal, the other two lines become the other line. So let's see, what kind of corresponding angles? So I noticed that 1 and 5 are both below, but on the same side. So you have angle 1 and angle 5. And then we also have angle 6 and angle 2. I'm going to write it in numerical order here. And then on the other side of that, you would have, say, 8 and 4. I don't think we want to go through and have to label all of these. It doesn't seem a good use of our time. I'm going to do one more. Angle 3 and 7 are both below their line, but on the same side. So we will include them in this. So angle 3 and angle 7. And it's possible we could find more if we made a different line a transversal, but I just want to kind of give you that idea. Now let's see if we can find some alternate interior angles. All right, well, I'm just going to stay with that same line there. If I want to do alternate interior and the blue line is my transversal, so that means this would be the interior. So alternate interior might be, say, angle 4 and angle 5. That would be one set. Maybe angle 2 and angle 7. Those are also alternate interior. And let's expand our horizons here. Let's make this, oh, I'm not sure what I just hit there. Let's make this a transversal, and we can continue. So if that's a transversal, then I can have, now this becomes my interior. So we would have angle 3 and 10. And we would also have angle 4 and angle 9. And I can find more, but I think that's gives us kind of the idea here. All right, now we want to find same side interior, which again, this is a leftover. Now we're calling them consecutive interior. And if you ever say same side interior, I'm totally going to go with it because it's what I'm used to. Consecutive interior angles, the CIA angles. All right, so we're still looking at interior, so we can go back to our two transversals. Notice that 2 and 5 are interior to those other lines. So I can say angle 2 and angle 5 are consecutive interior, which means on the other side 4 and 7 are also consecutive interior. And then if I use my green transversal, I have angle 3 and 9 our consecutive interior, and on the other side of the transversal you would have angle 4 and angle 10. And we can find more, but I think we've got it there. Alternate exterior. Let's try a transversal we haven't done yet. So let's try, we haven't looked at the relationship that would come off of this line here. So if this is my transversal, and I wanted to find some alternate exterior. So the green line is my transversal. So exterior is going to be out here and out here. It's not going to be between those two lines. So I would say 5, and if you follow the transversal, 11. Angle 5 and 11 are both exterior and on alternating sides, which means then 6 and 9 are also going to be exterior. And I think that's kind of a crazy diagram, so I think that's as much as I'm going to do right now. We could go through and find more, but I don't think it adds anything to the concept. So let's look here. We have the driveways at a bus station are shown below. It's a crazy bus station. Identify the transversal connecting the given angles, then classify the relationship between the pair of angles. And I think this is so important to be able to identify the transversal, because that's what the two angles will always share. They'll always be coming off the same transversal. So they have here angle 1 and angle 2. So I want to draw the line that goes between angle 1 and angle 2. So my transversal is going to be line V. And then what kind of angles are 1 and 2? Well, that means that the lines that create, the other line is the line that creates that angle. So that's going to be those two lines, X and S. So we see that 1 and 2 are both on top of the transversal and to the left of their respective lines. So they are corresponding angles. All right, now we have angle 2 and angle 3. So what I'm going to do is erase this and come back here. So angle 2 and angle 3. Okay, same line actually. So here's the line that goes between angle 2. I can kind of keep it going. And so the other line that makes up the angles is also here. I guess I didn't need to do that erasing. And so we notice that angle 2 and 3 are on, well, they share a transversal again of line V. And we notice they're on alternating sides of that, and they are both interior to the given lines that make them up, so that makes them alternate interior angles. And lastly, we have angle 4 and angle 5 down here, so I'm going to draw the transversal that goes from one to the other, and I'm just going to kind of extend it to kind of highlight that. So then we draw the lines. Let me get rid of these other markings. We draw the lines that make up those angles. So here's the line that makes up 4. Here's a line that makes up 5. So notice both these angles are interior to the two lines that were given, and they are on the same side of their transversal, or better yet, they are consecutive. So we have that line Y is going to be their transversal, and this is an example of the CIA, formerly known, or AKA, same side interior. All right, so this is your introduction into corresponding alternate interior, alternate exterior, consecutive interior. We will be using these relationships for the rest of the year pretty much.